Welcome back to The Explainer, everyone. Today we're exploring a seriously mind-bending concept that totally flips our understanding of the universe. Have you ever considered the possibility that extraterrestrial messages, actual tangible signals from advanced alien civilizations, have already crossed paths with Earth and we just completely missed them? We've been out here listening to an absolute ocean of cosmic noise, and while this sounds exactly like the plot of a sci-fi novel, recent scientific analysis suggests it's not only possible, it's actually highly plausible that we've simply been missing the call. Imagine someone sending you a gorgeous, high-definition video message, but you're sitting there trying to receive it on a pager from 1995. That's essentially the scale of the cosmic misconnection we're talking about today.
So, have we already missed them? For decades, humanity has been staring up at the night sky, straining our technological ears for some kind of cosmic hello. And because we haven't heard anything definitive yet, it's incredibly easy to just assume we're entirely alone in the dark. But we really need to rethink this narrative. This cosmic silence, it isn't necessarily proof of our isolation. Actually, as recent research is showing us, it might just point to a massive human limitation in how we've been looking. We could literally be staring out the wrong window, or listening on completely the wrong frequency, right as the ultimate interstellar parade goes passing by.
Okay, let's dive into this. To really understand what we might be missing out there, we have to establish exactly what a technosignature actually is. Put simply, it's any observable footprint or trace that proves advanced technology exists beyond our planet. These clues, whether they're intentional, directed messages sent straight our way, or just the everyday industrial byproducts of an alien civilization going about its daily business, travel across the vastness of space at the speed of light. Think of them as the ultimate cosmic breadcrumbs. And honestly, they are the only real evidence we can scan for over such unimaginable distances.
And this brilliantly illustrates exactly what we mean, a Dyson sphere. For a super advanced civilization that's actually harnessing the total energy of their host star, a megastructure like this generates an enormous, totally unnatural amount of waste heat. It basically acts as a massive, glowing infrared beacon screaming, "Hey, we are here," even if they aren't actively picking up a cosmic telephone to call us. We don't necessarily need them to broadcast a friendly greeting if we can just detect the colossal thermal footprint of their infrastructure.
But Dyson spheres aren't the only clues out there. Technosignatures come in all sorts of forms. We're talking directed laser pulses slicing right through the void, artificial objects swarming in orbit, or even highly unusual chemical modifications to a planet's atmosphere. Now here's the catch, and it's a big one. Most of these signatures are entirely ephemeral. Fast radio bursts, for instance, they can last mere milliseconds. Catching them requires an immense amount of luck because you literally have to be pointing your telescope at the exact right spot at the exact right millisecond. It is exactly like trying to photograph a lightning strike while blindfolded. However, durable technosignatures, things like long-lasting planetary modifications or giant structures, offer us a much wider, longer window for observation across the galaxy.
To figure out the actual mathematics of why we haven't found any of these yet, we turn to physicist Claudio Grimaldi. He recently published an incredibly rigorous statistical model in the Astronomical Journal. He really wanted to figure out the hard probability behind this mystery. Instead of just kind of guessing why the sky is so quiet, Grimaldi created a framework using principles of probability that are actually similar to thermodynamics and statistical mechanics. He calculated the true odds that artificial signals have washed over our planet since we first turned on our radio telescopes. This finally gives us hard, mathematical bounds on our search.
Grimaldi's framework evaluates three critical probabilities to map this whole thing out. First up, signal longevity, meaning does a directional laser beam last a microsecond, or does a diffuse radio wave broadcast for a millennium? Second, instrument keepability. Can our current tech here on Earth even register the specific frequency they might be using? And finally, time active, which asks how much time has actually passed since humanity launched our extraterrestrial research programs, which, let's be real, is barely a blink in cosmic time. He combined all these variables to see if our lack of success is a huge shock, or exactly what the math dictates.
So, the crucial point is that detecting a technosignature is incredibly difficult because it requires two strict conditions to be met perfectly and simultaneously. Step 1. The signal actually has to physically reach our planet, surviving what is a very long, degrading journey through the interstellar medium. Step 2. Earth's instruments must be sensitive enough and critically correctly oriented at that exact moment to catch it. If a signal happens to be broadcast on a frequency we simply aren't monitoring, or if we look away for just a second, it washes right over us. We could essentially be standing in a cosmic downpour of data, but holding our buckets completely upside down.
Let's move on and see how this builds a compelling case for a total paradigm shift.
Historically, our old strategy has been pretty myopic. We've been scanning our immediate galactic neighborhood, looking at stars just a few hundred light years away. But Grimaldi's math makes it abundantly clear that a new strategy is absolutely vital. We need to systematically examine massive, deep space volumes, extending our gaze thousands of light years away. And the logic here is profound. If technological emissions are durable and widespread throughout the Milky Way, artificially limiting our search to our own backyard drastically reduces our chances. Expanding our search volume exponentially increases our probability of finally intersecting with a signal.
Grimaldi's framework leaves us with a truly profound realization. To quote the model, the absence of discovery to date does not necessarily mean the non-existence of technological civilizations. An empty sky right now absolutely does not mean the universe is completely devoid of life. It simply tells us that our scope must expand, and our instrumental technology must continually improve so we can detect fainter, perhaps entirely unexpected types of emissions. It's a scientific call to broaden our horizons, folks, not a reason to abandon the search.
Which brings us to the ultimate question I want to leave you with today. If the signals really are out there, moving silently through the void, are we finally ready to listen? As our telescopes get larger, our computers get faster, and our search algorithms get infinitely smarter, we are steadily opening our cosmic ears. We're moving from peeking through a tiny keyhole to utilizing a massive, wide-angle lens on the universe. The messages might have been flying past us this whole time, but for the first time in human history, we might finally be building the exact right tools to catch them. Thank you so much for joining me for this explainer. Keep your eyes on the stars and stay curious.